Hi, this is an algebra review. Algebra is a set of rules for manipulating expressions and equations. An important concept is that the rules apply whether we are manipulating numbers, variables, or functions. You already know most of the rules because they follow the order of operations, also known as BEDMAS or PEMDAS. And we also follow the other rules like combining only like terms in polynomials and the power laws. There are shortcuts, but in general, we want to do BEDMAS in reverse, or SAMDEB. However, it's easier for most students to expand the brackets, collect like terms, move all the variables to one side, then solve. And this is the strategy for linear equations. We have to do something else with polynomials. So here's our first example. We want to expand. So 3x minus 6. Note that we have to distribute to each term. Minus 2x minus 2 times 5, that's minus 10, equals minus 4x. This is minus 4 times minus 6, so that's plus 24. Okay, we collect our like terms. 3x minus 2x, that's just x. Minus 6 minus 10, that's minus 16. And we have the same thing on the right-hand side. Now we need to do the inverse, which means add and subtract to both sides. We want to move all the variables to the left. We want to move all the constants to the right. So we need to do plus 4x on both sides. And we need to do plus 16 on both sides. And then we simplify. 4x plus x, that's 5x. The plus 16 and minus 16 cancel out. The negative 4x plus 4x cancel out, and 20 plus 16 is 40. We divide both sides by 5. And then we simplify. X equals 8. You've been told to do the opposite of add, multiply. But this is correctly called the inverse operation. So the inverse of add is subtract, inverse of multiply is divide, inverse of squared is square root, inverse of cubed is cube root. Here we have a power of negative 1. It's just a symbol. It doesn't actually mean to the power of negative 1. This means inverse sine. So the inverse of sine is inverse sine. And we have the similar thing for cosine and tangent. Although you haven't learned this yet, the inverse of the exponential function is ln, the natural ln of x. The inverse of 10 to the power of x is log x. And later on when you learn calculus, the inverse of the integral is the derivative. And substitution also has an inverse. It's just substituting back. Let's look at our next example. First step, we have brackets, so we expand everything. We have 1/5 x. A fifth times 20 is the same as 20 divided by 5, so that's just plus 4. Negative a third times 2, that's negative 2/3 x. Negative 1/3 times negative 9, that's the same as negative 9 divided by negative 3, so that's just positive 3. And we have negative 5 over 2x and minus 4. Okay, let's do the inverse operations to move all the variables to the left-hand side and move all the constants to the right-hand side. So let's just gather the like terms. And now we have plus 5 over 2x. We have plus 7, so we need a minus 7. And we have minus 5 over 2x plus 5 over 2x. These will cancel out. We have minus 4, and we have minus 7. So we're looking at a common denominator between 5, 3, and 2, and that would be 30. We have to multiply this by 6 over 6. So this is 6 over 30. We have to multiply this by 10 over 10. So that's minus 20 over 30. We have to multiply this by 15 over 15. So that's 75 over 30. And these two cancel out, and we have minus 11. Add the numerators, because we have a common denominator, and we get 61 over 30x. Now we have to do the inverse multiply. 61 over 30x equals negative 11. Multiply by 30 over 61. 30 over 61. These two cancel out. So we have minus 11 times 30. That's minus 330 over 61. An important concept in algebra is substitution. This can be used whenever you see the same expression. You simply substitute the corresponding expressions. And by using substitution, it's possible to eliminate extra variables. And we should be left with one variable and one equation. And although you've learned elimination and substitution in Math 10, you pretty much exclusively use substitution when you're doing math when it's other than system of linear equations. Okay, you've been taught one way to convert kilometers into miles. Here's another way. 1 mile equals 1.60934 kilometers. We need to figure out what 1 kilometer equals. So 1 kilometer equals, we need to divide both sides by this number, 1 over 1.60934 miles. Now we put 5, and we have a kilometer. So we substitute what a kilometer is worth. It's worth 1 over 1.60934 miles. Simplify this, and we get 3.11 miles. Here's another way to use substitution. We have one equation and another equation. Since this is an explicit equation for y, we substitute it in. 5x plus 2, bracket, and I'm going to do this in a different color, 3x minus 2, so that you can see the substitution clearly. So whatever y is equal, we substitute it in, and we substitute using brackets to avoid sign errors. Okay, now we expand. 2 times 3 is 6. 2 times negative 2 is minus 4, equals 7. Collect like terms. 11x minus 4, add 4 to both sides. And these will cancel out, so 11x equals 11. Divide both sides by 11. And we simplify, so x equals 1. Now we have to substitute it back into this equation. It's easier to do than this one. So y equals 3 times 1 minus 2. So y also equals 1. So an important reminder for substitution is you put brackets around the substituting expression to prevent any sign errors. Now, if you have more than 2 variables in your question, you need to solve for both variables like we did here. There's a y here, so we solve for x. We need to substitute back and solve for y. And just a reminder, the 3 main tools that you use for solving any problems are substitution, factorization, and algebra. Now, in Pre-Calc 12, you need to use some special algebraic methods from Pre-Calc 11, such as the quadratic formula, complete the square, and solving radical equations. And one important identity that you need to remember is the square root of x squared is the absolute value of x. Or the square root of x squared is equal to plus or minus x. A better understanding of the absolute value of x can be seen by using the piecewise function. The absolute value of x is equal to x if x is greater than or equal to 0. And it's equal to negative x if x is less than 0. You can replace x here with any expression. Here's an example. Find the domain of square root 4 minus x squared. So we need to check to see that the radicand is greater than or equal to 0. Let's isolate x. And divide by negative 1. So we need to flip the sign. Now the square root of x squared is less than or equal to 2. So the absolute value of x is less than or equal to 2. Let's bring this up here. So if x is greater than or equal to 0, we have x is less than or equal to 2. If x is less than 0, we have minus x is less than or equal to 2. We divide both sides by negative 1, so we need to flip the sign. And x is greater than or equal to negative 2. So our answer, negative 2 is less than or equal to x is less than or equal to 2. And just a reminder here and here, when multiplying or dividing by a negative, you must flip the inequality sign. Please try the exercises before looking at the solutions video, but this completes the review video.